Today we're actually doing the last lesson in Module 5. Can you believe it? 5.21 is the last lesson. We're going to spend tomorrow talking about some 3D shapes. We haven't talked about 3D shapes since the beginning of the module, so we're going to review that. The next Monday, Tuesday, Wednesday, Thursday, we're going to spend some reviewing. This is a big module. We've learned about volume, we've learned about area, and 2D and 3D figures. Okay, and then next Friday will be your Module 5 test. Does that make sense? Good. Today we're going to do is we are going to take everything we've learned about two-dimensional figures, so all different polygons or maybe things that aren't even polygons. And instead of sorting them, instead of classifying them, you are going to have to draw them based on the attributes that you are given. Does that make sense? So basically I'm going to describe something and then you have to draw it. Got it? Okay. This is a reminder that this is a complex figure because it's not just one prism. Could we cut it in a way that makes it two prisms? Yeah. What's one way we could cut it to make it two prisms? We could cut it right here. Do you agree? Or we could cut it like this. Yes? Okay. So looking at the measurements, let's cut it like this. Why do you think I would choose to cut it like this instead? Well, because I know this is 5 and this is 4. So can I find what this is? Huh? Yes? Good. Go ahead in your notebooks, draw this figure, label all the dimensions, and see if you can find the volume. Remember, the trick to doing these complex figures is to label all of the measurements before you do any calculations. Go. If we're going to cut it like this, let's find the measurements first of the yellow prism. Yellow prism would look something like this. Yes? Do you guys agree? Okay, what's the length, or what's the height, sorry, of the yellow prism? 3 centimeters. We can see it right here. Yes? Okay, what's the length from here to here? From here to here? 1, because we know this whole thing is 5, and this part is 4, so what's left over here must be 1 centimeter. Good. Okay, what about the width from here? Imagine it, right, from here to here. What's the width? Tell your table partners how you know that the width is 1 centimeter. Okay. So we know that the height is 3 because of right here. We know that the length is 1 because we have 5 minus 4, which would give us this part. Do you guys agree? Now the width is right here, right? Do you guys agree? Okay, so if I move the width, does the width ever change down here? So what's the width? Because of right here. Okay, so because of this guy right here, we know that the width is 1 centimeter. So now that we know that the length is 1, the width is 1, and the height is 3 centimeters, what is the volume of the yellow portion? 3 cubic centimeters. Good. Now let's talk about the blue portion. Go ahead and draw out the blue portion. It's long like this. Okay, and we have to find the dimensions. What is the length from here to here of the blue portion? From here to here, guys. What is it? How do you know it's 4 centimeters? Talk to your table group. Okay, so we know that the length is 4 centimeters. What's the width? We can see right here. Good. It's 1 centimeter. And now we just need the height. What's the height? Well, the whole thing is 3. This yellow part is 2, so what's left? Good. So the length is 4, the width is 1, and the height is 1. What's the volume of the blue portion? 4 cubic centimeters. So what's the total area of the whole complex figure, the yellow part plus the blue part? Well, it's 3 centimeters, 3 cubic centimeters, plus 4 cubic centimeters, which is 7 cubic centimeters. I wanted to show you this example to remind you that we know how to solve these kinds of problems, but also to show you that one good way is to draw out and label each individual section. Okay? So when you cut it into 2 parts, draw the yellow part and draw the blue part separately and label them. That will prevent you from making mistakes. Does that make sense? Good.